You might have taken the bus or car this morning. Then you have already been in touch with today's topic. It's about calibration. In the tire production, special sensors are used that can measure forces and torque simultaneously. And so that you can rely on product, an actual tire, you need to calibrate these sensors in the production. And today we are visiting GTM, a company from Bickenbach close to Darmstadt. And this company is specialized in calibration equipment and calibration of sensors. Hello Marcel.
Hello Christian. A warm welcome here at GTM in Bickenbach.
Thanks for the invitation. Could you give me a brief insight into the GTM world?
Yes, of course. Here at GTM, it's all about forces and torques. This means we offer force transducers, torque transducers, as well as multi-component transducers. On top of that, we are the first worldwide accredited calibration laboratory for multi-component sensors. In the last couple of years, we developed a world's first new fully automated calibration machine for multi-component transducers together with your measurement technology. And today we warmly invite you to take a closer look onto this highly innovative machine.
Thanks. That sounds super interesting. So let's take a look on the GTM machine, the new machine based on PC-based control from Beckhoff. Calibration of sensors is actually comparing a measured value to a much better reference. And this is daily business of calibration laboratories like GTM. Now we can take a look on the machine. With me is Daniel. Hi Daniel.
Hello Christian.
Could you describe the main difference between multi-component calibration to standard force calibration?
Yes, force is the vector, and this force has a magnitude, a direction, and force application points. And in multi-component calibration, we calibrate all these properties. In the classic force calibration, we only calibrate the magnitude.
So you fully described the physical system of this machine. What does GTM do different to others on the market?
Yeah. In Germany, there are 4 other calibration laboratories for multi-component transducers, and they concentrate on the calibration of multi-component transducers used in crash test dummies. We do not have such a limitation in our accreditation. So, for example, we can calibrate measurement platforms for the tire industry.
So that's a unique service from GTM,
yes,
and also a nice combination between accreditation and calibration technology.
Yeah.
So now we take a look on the machine itself. With me is Martin. Hi Martin.
Hi, hello.
Hi. You are the lead developer for this machine. What are the key facts, the 3 key facts that you see for this machine?
The 3 key facts are, at first, we have reduced the measurement uncertainty by factor 5 to 0.1%. We can generate forces in horizontal direction up to 200 kilonewton and in vertical direction up to 500 kilonewton, and all torques are up to 50 kilonewton meters. And the last thing is the calibration itself. It's fully automatic.
So fully automatic process and high forces, but why is this machine around about 5 meters? Why,
yes.
What makes it big?
The reason why is that the testing space have to be so big because of the customer's applications. If the customer want to have the introduction point here of the force and want to measure here, he need a lever arm. That's why we want to calibrate under realistic installation conditions.
Okay, and let's get practical. If I have a sensor, multi-component sensor, that needs to be recalibrated, I send this to GTM.
Yes.
What happens in the lab? What are the process steps that you take?
The multi-component transducer is fixed on the plate, on the groove plate, with our reference system. It is hidden in the bottom of the machine. Then the servo-driven hexapod is coupled with the transducer, backlash free. Then the calibration procedure can begin. After that, you can save the data.
Okay, I guess with that data, you create some kind of calibration sheet,
yes,
and provide the sensor back to the customer instead of me. And yeah, that's it. Thank you. So we learned about what calibration is. We saw a calibration machine here, multi-component calibration. with servo drives, measurement technology, and now we take a look on the heart of the machine. So we all comes together. Hello, Daniel.
Hello.
Hi. So we are now standing in front of the main cabinet. What are the main components of this?
Yeah. So here we see the PC-based control unit, the measurement system for the force transducers, and the drive controllers for the hexapod system.
So all together in one PC-based control system, but I see a drive system and a measurement technology.
Yeah.
How do they work together? Do they interfere somewhere, or how is it?
Yes, of course, you have to take care about the shielding concept. So we have different cable routes for the drive system and for the measurement cables.
Okay. And you use industrial-grade measurement technology. How did you qualify them to be used in such a precise calibration machine?
Yes, at the beginning we had to look into the data sheet of Becker, and we are looking for the properties which are interesting for us, but we are also accredited laboratory for voltage ratio. So we had the possibility to do a very critical investigation of terminals, and with the result that the terminals are well suited for our application, and the advantage is that they are integrated in the whole PC operated system.
A very deep view into this technology. Thanks for the insights. And yeah, that's it. So that was a nice tool for calibration itself and a very nice calibration machine for multi-component calibration. Thank you.